So yesterday we learned all these different types of angles. Today we're going to learn about, well, how are they related to each other? So these relationships that we're going to learn today only work if the lines are parallel. If the lines are not parallel, none of these are true. Okay? So the first one is called the corresponding angles postulate. Just as a reminder, in case you've forgotten, a postulate is a statement that we just agree is true without ever proving it's true. We all kind of go, yep, that looks like it's true, so we're going to just go ahead and go on. Okay? So this one says that if two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. So, walk in front of absolutely everybody. Or you could just, wait until later in class to throw it away. Okay, so why does this work? Well, I think it's pretty easy to see. You may remember, or you may not, from pre-algebra, talking about translations, where you take an object and you just slide it to a new place. If you don't, that's fine. Now you're learning it again. So a translation is where you just take something and you slide it to a new place. So what I'm going to do is I'm going to copy that line and that line. I'm going to copy angles 1, 2, 3, and 4. And what I'm going to do is take those and pick them up. Hey, Cameron.
I'm back.
Okay.
After we take the pictures.
And slide them over here. Do you see what happens?
They're the same.
They're the same. And notice, where does the 1 fit? Over the 5. And what kind of angles are 1 and 5? Corresponding. And where does the 2 go? To the 6. The 4 goes to the 7 and the 3 goes to the 8. The corresponding angles are going to be the same size because if I just slide them along the transversal, they're in exactly the same place and they're the same size. Yes, ma'am?
Are the big arrows, not the small arrows on either
Here?
end of the line, are those the arrows that indicate that they're parallel?
Indeed. Your book typically uses this kind. I usually use a closed-in one that's colored in.
That one would be easier to differentiate.
And that's part of why I like that one better. So on my worksheets, it'll always have that filled-in triangle. Okay? Yes?
So are they not corresponding if they're not parallel?
No, they still are corresponding. So let's look at that real quick because it brings up an important point. Let's say that I've got something that looks like this. We'll make them pretty obviously not parallel, right? So here I've got angles 1, 2, 3, and 4. I'll put them in the same order that the other ones are, 5, 6, 7, and 8. Right? If I slide this over, angle 1 and angle 5 are still corresponding angles. But are they going to be congruent? No, there's no relationship between them at all. So this relationship is only true if the lines are parallel.
The corresponding angles?
The corresponding angles are congruent only if the lines are parallel. Okay? So that allows us to do problems like this one. If I have these two angles, again, these are marked parallel to one another. What type of angles are these two angles? Yeah, they're corresponding, and then since the lines are parallel, we can conclude that they are congruent So, yes,
Why does it have the squiggle over the equal if they're congruent?
that is the symbol for congruent.
Oh, I thought it was just. I thought that was the. Oh no, I'm thinking of just the squiggly equals sign.
The squiggly equal sign
Is
means
it back?
approximately equal to. So 2x minus 45 is equal to x plus 30. Subtracting the x and adding the 45, we get x is 75. Okay? So, the corresponding angles, when the lines are parallel, the corresponding angles are going to be congruent. Again, if the lines are not parallel, the corresponding angles will not be congruent. All right, let's do this one down here at the bottom, which is going to lead us into our second page. So let's see if we can find the measures of these angles real quickly. What's the measure of angle A?
110.
110. Because what kind of angles are these two angles? Vertical angles. What's the measure of x going to be?
110.
Because why? Because they're corresponding angles formed by
Linear lines. Wait.
formed by linear pairs.
We always say linear pairs, so I just guessed. Parallel lines.
Formed by parallel lines. Since we have parallel lines crossed by a transversal, the corresponding angles are going to be congruent. Well, from there we can find y and z real easily, right? Y will be 110 and z will be 70. All right, before we go on, don't turn that page. Before we go on, thank you. Let's look at something. What type of angles are the 110 and the y? Alternate interior. It turns out that when the lines are parallel, the alternate interior angles are going to be congruent. What type of angles are the x and the a? Alternate exterior. When lines are parallel, the alternate exterior angles are going to be congruent. Okay? What type of angles are this original 110 and the z? Same side interiors. And what do we call two angles whose measures add up to 180? Supplementary. And that's really easy to remember. When lines are parallel, the same side interior angles are supplementary. It all starts with S. Okay? So I've demonstrated that this is true. I haven't proved that it's true, but we could go through and do a formal proof, and we'll learn a little bit more about formal proofs later in this unit. But I could prove that this is true based on what I know about vertical angles and linear pairs and corresponding angles, right? Okay? I did all this based on things I knew before. Anytime you do that, that's called a theorem. And we're about to do several of them. Aren't you glad I wrote all this out for you?
Yes.
So the alternate interior angles theorem says if two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. Likewise, if two parallel lines are cut by a transversal, then the pairs of alternate exterior angles are congruent. That's the alternate interior angle theorem and the alternate exterior angle theorem. And then the same side interior angle theorem says if two parallel lines are cut by a transversal, then the pairs of same side interior angles are supplementary. So with all those angles that we learned yesterday, if you have parallel lines, there's a relationship between them. They're either congruent or they're supplementary. The ones that are supplementary are the same side interior angles, and congruent is everything else. Okay? So this is just an example for each of those. Again, notice the lines are marked parallel to one another. This, by the way, the TH with an M underneath it, I had a professor years ago who used to abbreviate long words that way by doing the first couple of letters and then the last one with a line under it. I don't know where that comes from, but I just kind of picked it up. You're welcome to use it. You can abbreviate theorem a different way if you want to. That's just how I do it. It's not a big deal. So the alternate interior angle theorem here tells us that angle 2 is congruent to 6 and angle 7 is congruent to 3. The alternate exterior angle theorem tells us angle 1 is congruent to angle 5 and angle 8 is congruent to angle 4. And then the same side interior angles theorem tells us that 2 and 3 are supplementary and that 7 and 6 are supplementary. Okay? Let's do some example problems. Okay. I'm glad.
Geometry is cool.
So, let's take a look at this one. I've got these two angles, measures in terms of x. By the way, I know that looks a little bit like a bx. It's a 13x. For anyone who was confused by my poor penmanship. What type of angles are these two angles? Same side interiors. So since the lines are parallel, how would they be related to each other? They're supplementary. So on some of the problems on tonight's assignment, it's going to ask you to justify what you're doing. You just write out the name of the theorem. And you don't have to write the whole theorem. You can just write the name of it. Oh, that's not the color I wanted. It's a little light to see, though. Yes?
I understand they're supplementary because their sum is equal to 180, but I also like don't understand it at the same time.
How do you understand something and not understand it at the same time?
Because if they're parallel,
Uh-huh.
well, R and T are parallel. So,
You mean RS and TU?
yeah, and so they're gonna end like. I'm just confused on how.
Okay. So think about it this way. If I was to take this angle and translate it, oh, I forget that it does that. Hang on just a second. I apologize. This doesn't like it. Wonder if it'll do it now. Yep. See how it fits right there?
Yeah.
And that would be a linear pair, wouldn't it?
Oh, so it's like the inside of one and the outside of the other is the
Yeah.
Okay. That makes sense.
Yeah.
Thank you.
Yes.
How are we supposed to do that on the test?
Oh, I'm just saying how you can see it.
Oh, okay.
Here, we just look at it and go, those are same side interior angles. The same side interior angles theorem says when lines are parallel, the same side interior angles are going to be supplementary. So we'll just write an equation that says that. So it'll be 13x plus 23x is equal to 180. So it's 36x is 180. Divide both sides by 36. By Cameron. We get that x is 5. Then the measure of angle TUS then will be 23 times 5 is 115 degrees. Okay? All right, let's go on to number 2. So again, I have parallel lines that are crossed by a transversal, so all those new relationships are going to be true. Now, what type of angles are the 2x plus 10 and the 3x minus 15? Alternate interior angles. Okay. And when I have parallel lines, what do I know about alternate interior angles? They're congruent because of the alternate interior angles theorem. So I know then that 2x plus 10 will be equal to 3x minus 15. Subtracting the 2x and adding the 15 gives me 25 is equal to x. Sorry? Okay. The measure of angle ABD then will be 2 times 25 plus 10, which is 60 degrees. Okay, one more problem. This one is more involved in terms of the algebra that you have to do, and you have to be careful about what you say and what you don't say. Okay? So, for this problem, I've got 3 lines that are all parallel to each other and 2 different lines that are crossing those 3 lines. So, here's what you have to be careful about. Do you agree that if this angle is 60, that this angle is also 60?
Yeah.
Is this a trick question?
Not so far.
The answer was a trick answer.
You mean this problem?
No, not mine.
Okay. Now, what type of angles are the 25x plus 5y and the 60?
Supplementary side.
Same side interiors. Are they supplementary? No.
What?
And here's the deal. The theorem says if 2 parallel lines are cut by a transversal, then the same side interior angles are supplementary. If I'm looking at these 2 angles, do I have 2 parallel lines cut by a transversal?
No.
No. I don't have any parallel lines.
The only things that are parallel in this whole equation are the transversals themselves.
Well, so maybe I'm thinking about it wrong. Maybe I should be thinking about the transversals not as going up and down, but instead, maybe I should be thinking of the transversals as going from side to side. I wonder if this will work. Hang on a second. I'm always interested to see when this... Oh, yep. So go like this. And like this for your 2 transversals. Now, what type of angles are the 125 and the 2x plus 5y?
Alternate exterior angles.
Alternate exterior, very nice. So what, am I crossing parallel lines?
Yeah.
Yes, this is going through several lines that are parallel. So what's the relationship that those 2 angles are going to have? They're going to be congruent. So I can write an equation, 25x plus 5y is equal to 125. Here's where the second difficulty comes in. Can I solve that for x or for y? I could get x equals something in terms of y, or y equals something in terms of x, but I can't find x and y. Well, that means I need another equation. Well, what type of angles are these 2 angles? Same side interior angles. Is my transversal there crossing parallel lines? Yes, so what should be true about those? They'll be supplementary. Now, before you write that equation, let me ask you a question. What's easier to work with, congruent angles or supplementary angles? Congruent angles. Well, how much is this angle?
120 degrees.
120. And what type of angles are this 120 and the 25x plus 4y? Corresponding. Oh. So what is the relationship between those 2? They're congruent because my transversal is crossing parallel lines. So I'm going to write that one right underneath this one. 25x plus 4y is equal to 120. Now I can do a pretty simple system of equations, Jackson's favorite thing. Notice if I just subtract the second equation from the first one, I can eliminate the x's. That's pretty nice, because 25x minus 25x is no x's, and 5y minus 4y is just y, and 125 minus 120 is 5. Now we can substitute to find the other variable. Does it matter which one? No. Anyone have a preference?
For the one with the 4y.
Okay. I think that's a good choice. Why did you pick that one?
Because 120 is smaller than 125, and 4 is smaller than 5.
Okay, that's fair. I picked it because 4 times 5 is 20, and subtracting that from 120 is really easy.
Wouldn't it be the same thing? 5 times 5 is 25 and it's 125.
Yeah, it works out the same way. Either way, we get x is 4. So you'll have at least one like this on your assignment tonight, which is in the book. Interestingly enough, although you guys have almost done a complete other unit, regular geometry did this yesterday.
That's crazy.
We just go faster, so we can. There's more topics. We'll cover some topics that they won't cover. That's the difference between the two classes. That, and I do ask you guys harder things than I ask them, generally speaking. Although there's a fair bit of overlap.